Have you ever stopped to think about how you can bend down to tie your shoes, twist around to grab something from the back seat, and still stand up perfectly straight? Well, that's all thanks to one of the most incredible pieces of natural engineering in your body. Today, we're going to dive deep into that architectural marvel, your spine. So let's just jump right in with the big question, the paradox that makes the spine so fascinating. How on earth can one single structure be both a super rigid pillar, for support, and at the same time, a crazy flexible chain for movement? It seems impossible, right? But it's a design puzzle that our bodies have solved brilliantly. So meet our main character for today, the vertebral column. And get this, it's not just one long bone. It's actually a complex, elegant stack of 26 individual, irregular bones called vertebrae. You can see how they're grouped into 5 different regions here, each with its own specific job to do.
Okay, so what exactly is on its job description? Let's break down the core functions of this incredible piece of work.
The spine really has this amazing dual personality. On one hand, it's a fortress. It's this bony armor that literally protects the super delicate spinal cord. It's also the central pillar holding us up, anchoring our ribs, our muscles, the whole shebang. But then, on the other hand, it's this super flexible chain that gives us an incredible range of motion. It's a total masterpiece of protection and mobility, all rolled into one. So how does the spine pull off this amazing balancing act? Well, the secret isn't just in the bones themselves, but in how they're all stacked together. See, it's not a straight rod. It's a masterful S-curve.
This quote really hits the nail on the head. That S shape, those curves, they let the spine act like a spring, absorbing the shock of every single step you take. I mean, just imagine for a second if your spine was a straight, rigid pole. Every time you jumped, or even just ran, it would send this awful, jarring shockwave right up to your brain. That S-curve is what makes everything smooth.
And what's really wild is that we aren't even born with this S-curve. A baby's spine is just one big C shape. The S-curve is something we actually earn as we grow. That first curve, in the neck, it forms when a baby starts to lift its head and look around. The second one, in the lower back, develops as they learn to sit up, stand, and then take those first wobbly steps. Our spine literally reshapes itself based on what we need it to do. How cool is that? All right, let's get just a little bit technical here. The curves we're born with, that C shape in the middle back and bottom, are called primary or kyphotic curves. The curves that show up later in the neck and the low back are called secondary or lordotic curves. So this whole transformation from a simple C to a complex, springy S is just a beautiful example of our bodies adapting to the world.
Okay, now for the fun part. Let's take a little tour down the spine, region by region, and you'll see how the shape of each part is perfectly designed for its job. First stop, the cervical spine. These are the 7 smallest, lightest vertebrae right up in your neck. Think of them as the delicate director of your head. Their job isn't about heavy lifting, it's all about mobility, letting you turn your head, look up, look down, and position your eyes and ears to take in the world. And inside this region, the top 2 vertebrae are the real superstars. C1 is called the atlas, like the Greek titan who held up the world? Well, this bone holds up your head. C2, right below it, is the axis. It has this little peg that sticks up, and the atlas pivots around it. This is what lets you shake your head no. And the way they sit together lets you nod yes. So yeah, your yes and no movements, you can thank your atlas and axis for that. Okay, moving on down, we get to the 12 thoracic vertebrae. These guys are the stable anchors. They're locked in with your ribs, forming the back wall of your rib cage. They're basically a protective fortress for your heart and lungs. So here, flexibility totally takes a backseat to protection and stability. And finally, we arrive at the lumbar spine. Just 5 vertebrae, but man, are they the heavy lifters. These are the biggest, beefiest, strongest vertebrae of the bunch, and for a very good reason. They have to support the weight of your entire upper body. They are literally the foundation of the skyscraper. This little chart here is a perfect summary of how form follows function. Just look at the body shapes. The cervicals are small and oval, built for movement. The thoracics are heart-shaped, perfect for anchoring the ribs. And the lumbars? Massive and kidney-shaped, built for serious support. You can see this pattern all the way down. Each region is just perfectly designed for its own unique job. So we mentioned the thoracic spine works with the ribs. Let's zoom in on that for a second and see how they build that protective thoracic cage. We've all got 12 pairs of ribs. But guess what? They're not all the same. The top 7 pairs are the true ribs. They connect right to your breastbone. Then you have the false ribs, pairs 8, 9, and 10. They're a bit more clever. They connect to the cartilage of the rib just above them. And then you've got the floating ribs, the last 2 pairs. They're kind of the rebels of the rib cage. No connection at the front at all. But here is where it gets really brilliant. Your rib cage is not a rigid box. It's a dynamic machine that expands every time you breathe. And these 3 analogies explain it perfectly. The upper ribs move like a pump handle, going up and forward. The middle ribs move like a bucket handle, swinging out to the sides. And the bottom floating ribs move like calipers, opening and closing. It's this beautiful, coordinated, mechanical dance that lets you breathe. All right, let's head all the way down to the foundation of the spine, where we find the all-important structures that cushion and support this whole incredible tower. Tucked between pretty much every vertebra is an intervertebral disc. These are your body's personal, built-in shock absorbers. And each one is kind of like a jelly donut. Seriously, it's got this tough, fibrous outer ring and a soft, squishy, gel-like center. This design is genius. It lets the discs be incredibly strong, but also compressible, just soaking up the impact of every move you make. And that jelly donut design is so important. When a disc is healthy, it's the perfect cushion. But if that tough outer ring gets a tear, that jelly-like center can start to bulge or even leak out. And that's what we call a herniated disc. That bulge can press on the spinal nerves right next to it, which, as you can imagine, can cause some serious pain. It's a pretty powerful reminder of how finely tuned this system is. So our journey down the spine ends right here at its foundation, the sacrum. This big triangular bone is actually 5 vertebrae that fuse together as we developed. It's the absolute cornerstone of the whole structure. It locks into your hip bones and transfers the entire weight of your upper body down to your legs. It is the solid base that this whole architectural marvel rests on. So from that delicate director in your neck to the heavy lifter in your lower back, your spine is just an incredible story of adaptation. It's a living structure designed for a whole lifetime of movement. It's truly a masterpiece that lets you stand tall, bend, and twist through life. So the final question I want to leave you with is a simple one. How are you taking care of yours?